Okay, so we are doing answers for causal inference and statistics, the book right there you see. And we are on question 1.24, which is a multi-parter. I'm going to let you read this for yourself, but basically what is being described is that there is some kind of drug trial taking place, and for some reason, all of the patients are kept, I guess, in a hospital, and those that are receiving the drug are going to be kept in one ward, and those not receiving the drug or receiving a placebo are kept in a separate ward. And each ward has a different nurse, and the nurse that is seen to the drug ward, in other words, people not receiving placebo, she observes people being depressed or not, and when people are depressed, she gives them a lollipop. Okay? And now the trial goes through, and what we find is that the people that took the drug do better than the people who took the placebo. But if we partition the data according to who received a lollipop, we get a Simpson's paradox, or a reversal. In other words, even though when we look at the total data, drug recipients did better than placebo recipients, but if we look at who took the lollipop or who received a lollipop, they do worse. And if we look at who didn't receive a lollipop, they do worse. Okay, and so that's the Simpson's paradox here, and that's what's being described. Okay, and so question one is, before we get to parts A through E, I always want to draw a picture of what's taking place here, okay? And so that's what I've drawn here. So we have a drug, and that drug is affecting outcome. The ward to which a patient is assigned depends on the drug, and the nurse that they see is a function of the ward assignment. So drug is kind of causing nurse through ward assignment, and the nurse, along with depression, is determining who gets a lollipop. Okay? And so I think we're supposed to assume that only the drug patients were eligible for a lollipop. Okay, so we have all of this. I'm further assuming that that depressed patients may track with case severity. So sicker people, for whatever the drug is trying to treat or whatever, may be more likely to be depressed. And of course, case outcomes are going to be affected by case severity. Okay. So question one is the drug beneficial to the population or harmful? Okay, and so really I think what this is asking us is, should we look at the aggregated data or the lollipop partitioned data? Okay, so as I look at this, as I look at my picture here, I am going to say that we should look at the aggregated data. And the reason is because drug is affecting outcome, but lollipop is not. Okay, lollipop is not affecting outcome, and so it does not make sense then to partition on lollipop. Okay. Question B is, does the answer that I just gave contradict with the gender example that's presented earlier in the chapter? And you'd have to look at what that, you'd have to go back and look at that example. But in that example, sex or gender was a cause of outcome as well as of drug. So does our answer contradict? Well, no, because the criteria that we used for that for our assessment in the gender example was what was causing the outcome, and in that case, sex really was one of the causes of outcome. Okay. Part C is draw a graph that more or less captures the story. That's what we did up here, so we've already done that. Now part D is a little weird. So it says, how would you explain the emergence of the Simpsons reversal in the story? Okay, so when I actually sat down to do this, I realized, okay, well, there's some problems here. Okay, so the first thing I want to address is that sometimes a question like this can be difficult because when we are, when I'm going to explain something, in this case, why people with lollipop do worse and people without lollipop do worse or something like that, my tendency is to want to give an explanation in terms of the variables that are presented here: lollipop, drug, case severity, etc. Okay, but Simpson's paradox is not the cause of Simpson's paradox is not really within these variables. It is a coincidence amongst the group sizes and however you've partitioned the groups and those outcomes. Okay, and so that coincidence is not indicated on our picture here. All right, so so any explanation really comes down to, I think, a table of the groups and how many participants were in those groups and what the effect was in those groups. That is the explanation. It is just the coincidence of these group sizes. Okay, but now when I actually started to try to create the table, I realized that there's a problem. And that problem is that I'm assuming, and I think that the question implies, that nobody in the placebo group got a lollipop. So in other words, there is no group to compare, there's no group, placebo group, to compare lollipop with to the drug lollipop group. So we can't do it. And even if we try to say, okay, well, that's fine, then we'll just compare drug lollipop and drug no lollipop to placebo no lollipop. When you go through and you try to work out the numbers, you can't make Simpson's paradox here. You can't make it work here, okay? The explanation for why is actually a little bit hard for me to state. I can see why it would not work, but it's hard to state, and so I'll just trust you to go play with all of the numbers there. Okay, but if we assume that some of the people in the placebo group did receive a lollipop, maybe they randomly received these lollipops, well, now we can induce Simpson's paradox here. Okay, and again, all that we're in order to induce Simpson's paradox here, all that we have to do is ensure that the criteria is met. Basically, that the combined numbers, that the drug group does better than the placebo group, which they do here, but then doctor the other numbers so that in each subgroup, the drug group is doing worse than the placebo group. Okay, and so you can play with those. All right. Okay, finally, would your answer change? And the answer that they're referring to, I think, is to part A, where it's really asking, should we look at aggregated or partition data? Would that answer change if we knew that the lollipops were handed out a day after the study instead of before the study? And so kind of what's being implied here is that, okay, well, if something happens after the outcome, it can't be a cause of the outcome. And that's true enough. But in this case, our answer wouldn't change because we already said that lollipop is not a cause of outcome. So our answer wouldn't change. Okay, that's it.